Right, I hope you have filled in the spaces in that diagram. So now, let's check. What are the natures? So what do we have there in terms of the x and the y here? Which one? Is this positive or negative? Positive. This one? Positive again. Kana, what is this thing called? What is this thing called? This thing in grade 7 is called what? This is Cartesian plane. So don't say what you see here. So this is Cartesian plane because we can see that we have the x and the y there again. So this is called the Cartesian plane, and of course here is the origin where we have the 90 degrees. So this one is a Cartesian plane, right? This side, what is the nature of the x and the y? What do you have? X is what? Y is what? Then this side, what is the nature of the x and the y? X is what? Y is what? You see that again? There are people that confuses this. So make sure that you take this opportunity to make sure about the Cartesian plane, because we're going to use it more and more and more. Right, then on the fourth quadrant, x is what? Y is what? X is? Y is what? Negative. Is that clear? Alright, now this is our Cartesian plane that we know in the lower grades. Now we're going to employ our right angle triangle in a Cartesian plane. Now this thing is divided into 4 again. So, and then it's making it's kind of, with our right angle triangle, we're going to make a rotation of maybe an arm or whatever. But now this one is just the x and the y's, which means it's our Cartesian plane. Then we're going to take that right angle triangle that we know, we put it here in the Cartesian plane. And then what we do there, we're going to measure an acute angle with, now the line that we're going to take to measure the acute angle, it means it will be the one that will be giving us the reference angle, so that we can point the the opposite and the hypotenuse again. All right, now let's employ we're still in the Cartesian plane. Nowhere else. We're still in the Cartesian plane. I know you have some info about what is the cast diagram, but we're still going there. So let's go through. Now, in this Cartesian plane, if we have a point, if we have a point, maybe or line, then we have a point here. This is point this way. We have these 2 points. Of course, we know here's the origin, O and O, which is origin is called O point, which is coordinates 0 and 0 again. Is that correct? And then what is the coordinates here? At this point. What is the coordinates at this point? Yeah? What is the coordinates at this point? Y? X and 0. Alright. Hey, listen. Because we know that along the x-axis, the y value is what? 0. Is that correct? Then that's why at this point we have the x and what? And 0 again. And now what you can observe is that this from 0 to here. Do you know how much is it? That's why we just give it x. I grew up moving along the value of x. But for the value of y here, we know y at the x-axis is what? 0. That's why the coordinate there is what? X and 0. Now we want to rotate this arm. Do you agree with me? If I rotate this one, it's going to move something like this. Yeah? Now when you're rotating this, we are rotating it anti-clockwise so that we are measuring the positive angles. They agree that the anti-clockwise direction is the negative angle. So not negative but positive. But moving clockwise like the athletes when they are running. Again, you see in which direction they are running. They are running anti-clockwise. Then it's decided that it's a positive angle. So think of them. I don't know the athletic. Everyone go ground there practice what's happening. So we're moving. If it is our ground will be rotating that way. Okay? So rotating that way, we call it a positive angle. So now if we take this arm and then we try to rotate it, it will be something like this again. So it will be moving like that again. So if it's moving like that, of course, even maybe it's not drawn to scale, but that will be the thing there. All right, then if that arm is rotating, then we can be having that point will be moved here. Now, what will be the point? X end. Now this will be X end. You agree with me there? So now this side, or rather we measure really what? An angle here. Okay? So I measure that angle. We see that angle is what? An acute angle. Okay? So if that is an acute angle, we know that if that was an acute angle, if we join a line there, that is making a right angle triangle there. Okay? So meaning, let's erase this one for now. Now we can put our right angle triangle there. So now it means again from here to here is the same as from here to here. Is that it? So from here to here or here to here, what is the value of the x? So it means this side will be x again. Then what is the value from here to here? That will be 1. Now can you see that this x and y represent this line, and this this x represent this one distance from here to here, this y represent from here to here. Can you see that? All right. Then now we have the other side there. We have the other side there. But now for the fact that this arm will be rotating, and then when you're rotating, we end up making what? A circle again. So if you're making a circle, end up making a circle, and there was an arm rotating from here. What is this called? So this side will be our radius. Then we call it what? We call it R. So it means that line will be rotating in that way. That will be our R. Now we said this is an acute angle, and then that's of course this will be what? We can give it an angle theta. Is that clear? So now if this one is angle theta, now can you see that we can define our sine theta, cos theta, and tan theta in a Cartesian plane? Again, so let's define them in this one. So if we have the sine of theta, what will be what? We know we're going to use our soccer tool. So what will be the thing here? What will be the ratio? You can see that when you are here, what is the opposite? The opposite is this one. Again, then that is what? 1 over the hypotenuse. This is opposite to 90. This is hypotenuse. That will be R. Can you see that? So running our side in terms of a Cartesian plane, it will be defined in terms of the x, y, r. Again, so hence there will be y over r. So can we go to the cos? So cos of theta over x over r. Can you see that? So the tan of theta, it will be how much? Y over x. So this is our trig ratios in terms of what? X, Y, R. But we are still using our SOHCAHTOA, but now we are in what? We are in a Cartesian plane, hence we have to use what? We have to use the X, Y, R. But the definition is opposite over the hypotenuse and so on. Again? Is there any question? Yeah? Alright. Move. You can move silently. Alright, from there. Now remember the arm is still rotating again. Let's rotate it again. Now this point as it's rotating, you can see that now this may rotate and end up maybe at this point. Okay, it can rotate. Maybe let's try to make it. It can rotate again to come to this quadrant again. So this will be quarter number 2, which is named quadrant 2. Sorry for that. And then now we agree that from here. Now where is the angle starting? Now the angle again starting from this level again. Now what is angle starting from this level? You can see that. Now tell me, is this angle here? Maybe let's name it what? Alpha. Is that angle alpha acute angle? It's not acute angle. Now if it's not acute angle, it means we might fail to use it again. We might fail to use that angle. But now we might have some information to do and to use it again. So now all the way from this way to up to here, this point, what will be the angle? 180. So it means this angle all the way from here up to here is 180. But I know this piece. So that meaning this piece plus alpha is how much? 180. Again? Okay. So if it's 180, so what will be this angle? What will be this small space? 180 minus? That's why I said you must do your math nicely. Because I say, what can we give this angle? Maybe let's give it, this is O, let's say P, Q. Let's give it Q, okay? I mean O angle, Q angle O, and then let's put another point here maybe, and let's put it here again. Of course, this is going to end up making that 90, okay? So we'll end up making that 90 there, okay? So that now why are we doing like this? We want our acute angle because we know how to work with acute angle in a right angle triangle, okay? So we need our acute angle that should be here. All right, let's name it. All right, if we'll say Q angle O T. Wait, what? Q kazamo angle O T. So that this angle is made by line OQ, QO and OC. That is made with that space again. So that is named Q, point on that angle, which is O, and another line to another point will relate that line. Plus what? Plus this one again is named alpha. Equals to how much? Why are they equals to 180? Angles on a straight line or some angles of a straight line again. Some angles of a straight line. Yes. Supplemented what? Speak it clear. No, we must mention straight line. There are other supplementary angles without a straight line. So we cannot say supplementary angle. Yes. So, but just say, maybe we can say angles of a straight line, still fine. Because angles of straight line, we know that they are 180 degrees, again. But my plea is that make sure that you use to complete that so that you don't forget. Because you can use to angles of a straight line. At the end, you might forget what angles of a straight line are doing. What are they adding to, okay? So, but if you did this, you can say angles of a straight line because that keeps in your mind that if they are adding to 180, again. So you can simply say angles of a straight line because you wrote this one. Now, what are you going to have now? Q angle OT is how much? You know, okay? 180 degrees minus alpha. So it means it's this piece here. Is that correct? Yeah? 180 degrees minus. And indeed, if I take 180 and I minus this whole angle, I'm going to get an acute angle. Is that correct? I'm taking this 180 and minus this bigger angle. That is more than 90. Obviously, what I'm going to get is less than 90. Okay? Again, it's 180. Then 180 minus or above 90. Then number is less than 90, which is an acute angle. And this is the angle that is an acute angle. Is that clear? Now, I want you to observe something. You'll see what is going on. I'm sure some others, they are seeing the light. Where these things we just said, this is equals to this one. When we are this one, we are in this quadrant, but we didn't clearly show you. But now we are seeing where they are coming from. So that at the end, we are going just to take them as the rules. Again, now we are just showing them, but at the end, we're showing them as the rules. You don't have to go through that. You know that it equals to the other one. All right, we are having our acute angle here. Okay. Now, if we have our acute angle, let's go and write what? Our sine. Okay. So, of course, according to our Cartesian plane, what will be this from here to here? According to the Cartesian plane, in the terms, what will be x from here to here? Yeah, we can write the coordinates here. Come on, coordinates x negative x again. The y positive again. It means here negative positive 1. So whenever you are in this quadrant, make sure that looking at your diagram, your value of x is negative. Your value of y is positive. So don't ignore that, okay? If you ignore that, we're going to have a problem. All right, now, let's see, using that. This is the angle, the acute that we know that we're going to use, okay? Now, let's do this one. Sine of that. Let me erase here. So that you don't think you are in the fourth quadrant. You are just here writing the things of the second quadrant. All right, here, sine into what? Which angle should I use? I should simply use 180 degrees minus alpha. You can see that again. Even this angle we can fit number 10, but just not want to go there. But we can fit it again and see what's going on. All right. Now 180 minus alpha. Now what will be the sine of 180 minus alpha? Over y over r. Is that clear? And it's positive. Yeah? Now let's go to quadrant number 1. Is there anything equal to that one? Is there anything that equals to y over r? Which one is it? Over the sine of theta. Again. So if that's the sine of theta, now the difference will be the angle. It means I must maybe show you another diagram. Yes, but now looking at that, it's fine. It's the same as y over r. But you can see that it's the same as when you use the angle that is in first quadrant. Can you see that? It's the same as we use the angle as in the first quadrant. So meaning that whenever you are here, doesn't matter where you are. This 180 there, it will be just used kind of a reference, or we are at some point, but we are looking for that angle that we are given. Can you see that? Okay, let's write another one. We'll come back to this one. What do we have? Cos of 180 degrees minus alpha. What will be there? It will be what? Negative x over r. Negative x over r. So now, of course, you can see that that would be negative x over r. So now let's check this other one. Tan of 180 degrees minus alpha. What are you going to get? Y over negative x. Can you see that? So what is remaining is that even if I use 180 minus 180 minus 180 minus, but I'm going to pick out my angle again, because now this one you can see that is the same as when I'm first in quadrant saying sine of angle equals to this other one is y over r. So meaning that even if I'm here, I don't have to use what? I don't have to use 180 minus. What? I can use this alpha as it was given, as if I'm in the first quadrant. What? Because now I can see that this will still converge to the same ratio as I used in the first quadrant. Is that clear? But now, what you want to highlight is that, okay, it means this one, if this angle, because this, remember, this acute angle can be in the first quadrant. Again, the acute angle belongs to the first quadrant. So it means this is the same as what? This can be the same as sine of alpha. Both of them can be y over r. What? Does it make sense? So, 180 minus theta. This angle is also an acute that can be in the first quadrant. And in the first quadrant, we still have what? But this case, what is the difference? This is this one. Okay? In our first quadrant, we have this again. Then the negative is not there. But so it means this x over r is the same as I can say cos of alpha. But now you can see that the cos in that quadrant is what? Negative. But the ratio is the same, again. But with the sign of negative. So the peg of numerator and denominator is the same, but they have what? Negative. So meaning, doesn't matter in which quadrant, I can still know that base will remain x over r. But which quadrant are you, again? So that will be positive or negative. This one, it means it can be the same as the negative here. So this one is equal to what? What are the negative tan of alpha? Because y over x is in the first quadrant again. So meaning the only change is what? Is the sign. So meaning that in the second quadrant, but take note of this, 180 minus, can you see that we're going to end up with our angle? But we'll use the diagram. So now is a rule that if we see sine 180 minus, then we're going to end up with the sine of that angle. Is that clear? So, but that sine of angle, it will depend on which quadrant are you, okay? It's fine. Then now, it means going on, I'm not going to use this one, because I know whatever that I'm going to subtract, it will be something to equivalent in the first quadrant, okay? Agree, you can see that this is equivalent to something in first quadrant. This part here, only this part, without this negative, is equivalent to someone in the first quadrant. Okay? But because I'm in the second quadrant, then this is giving me negative of that ratio. So rather, I'm no longer going to continue the 180 minus 180 plus, but you can see that is going on. We'll check them soon on the other part. So, but the key now, I wanted to show that in the first quadrant, in the second quadrant, sine is what? Positive. Cos is what? Tan is what? According to the diagram. Okay. So this is what we are seeing. So now that's why in first quadrant we have what? All functions or ratios are positive. In this one we only have what? Sine. So we're only writing the ones that are positive. The one that is not there, it means it will be negative. Okay? So now this will continue to the third quadrant. Let's see if we have what in the third quadrant. So if you are in this quadrant, of course you know this will be negative x again. This will be y, and our 90 is there. And this one is maybe it's beta. So you see that if you are here, you can see that is 180 plus again. Because if you are this one here will be 180, so that will be 180 plus a certain number, which means that will give us a beta. Again. So now, but we don't need to use that. We know that it will be equivalent to a certain ratio in the first quadrant. Again. So now it means we're going to use that beta as if it's in the first quadrant. You know the reason again, and you will be convinced that there will be someone equivalent to that ratio. Just that here it will depend now in another quadrant, but the ratio will change. That's only the sign again. All right, now it means in here I will simply say sine of beta again. So sine beta over again. So you need to show the direction or here guy again. Over again. Y over. This is negative y again, not positive. Negative y over r. So can you observe that in that quadrant sign is what? Negative. Cos of beta equals to what are you going to have? Minus x over r. Can you observe that cos is negative? So this is going to be what? Tan of beta is what? Negative y over negative x. So this is the same as y over x, because negative divided by negative is positive. So you can see that in the fourth quadrant only tan is positive. Yes? Yeah? You are in the third quadrant again, not fourth but third again. So in the third quadrant you can see that the tan is the one that is only positive. So now if you are in this quadrant, what will be the value of x? What will be the value of x? Plus, what will be the value of y? And then of course, our angle, show the angle, will start from here up until here. Show the arrow, showing in which direction are you moving, okay? Don't just write that triangle only. Show that the angle will start from the x-axis this side and up until you get to the fourth quadrant, okay? Alright, now what will be the sign here? Sine of beta. Oh, let's give it another thing. What can we give it? Let's give it a theta again on this one. Let's give it theta again. So sine of theta, it will be what? It will be Sine of theta, negative y over r. So you can see sine is what? Negative. Cos of theta is how much? X over. So you can see that ratio is what? Positive. Tan of theta, negative y over x. So you can see the tan is what? Negative. So running only cos is what? In the fourth quadrant. So this will take us to what do you know and what do you like, which is what? The cast diagram. Now if now it's cast diagram, now we'll be showing that 0 degrees. We are not just showing the Cartesian plane, but it's combination of the two. 0 degrees, and then we are rotating in anti-clockwise. So mo go by 90 degrees. Mo go by 180 degrees. Then mo go by, and then mo go by. Now 360, it means it closed that cycle. Now the cycle of the rotation is closed. Then we'll, in the near future, we'll be seeing more than one rotation. Then you must be aware of that. We'll talk about that. But now it shows that we only rotated once and the cycle is closed again. And then we are rotating with the R again. The arm with R, then we are rotating with the radius, and then up until come this one. Now that's when we say, oh, all the things in here are positive. Only sine is what? Come up. Come up. So that is what cast diagram is saving many names again. So people are giving 8 many names. All station to Cape Town, all students take coffee, some are insulting others with this. Yeah. As well as you can sing that song during the exam, you sing that in your heart so that you can make sure that you do the right thing. All right. Is there any question so far? Okay. So there is no question so far. All right. Now, this are our cast diagram. Now, based on the cast diagram, now I also did something that is called a reduction. I did something called a reduction. Just that I didn't complete it. Now, this is what would be called a reduction. Again, why I was saying the reduction? We're just taking the bigger numbers that are more than acute angle, and we're trying to work them in terms of the acute angles. Again, even though that is not specifically what I'm saying, but when we try to take that bigger number and put it in a quadrant. Let's say we have a number that is 150. Obviously, it's over acute angle again. But that number, which is an acute angle, now when you try to put it in this quadrant, of course, there will be a smaller number. We will compare 180. When you subtract that number and 180, there will be left with what? An acute angle. So that it means we are reducing 150 to something that is less than 90, which is an acute angle. We know that there is a cousin of that smaller angle that is here. That will be equivalent to it in the first quadrant. Am I making sense? If the number here is 150 degrees, of course, in this quadrant, the number is 150. 150 belongs to second quadrant, again. Or before that, let's start. What are the numbers belonging to this quadrant? First quadrant? Maybe here. Let's use this one. What are the numbers belonging to this quadrant? Yeah? You're saying 90. This 90, is it in this quadrant? Okay, this 90 is in the first quadrant or second quadrant? First. So what is the number in the second quadrant? Oh, 90 go first, TV go second. So I'm saying exactly 90. When you say plus, you increase that 90. When you say minus, you decrease that number. So I'm saying 90 degrees. Where is it? In which quadrant is it? Yes. So that 90 degrees is between first quadrant and second quadrant. So when you are saying 90, you don't know where you are. You are in the middle of the ocean. So you are between two things. You cannot say I'm this side or this side. Don't know, I will still come to other things. Now we're doing the proper things again. So we're saying what is 90? So now you just know that 90 is not in any quadrant. But when you're going to separate it or add it, now that's when it gets into jump into the another quadrant. Again? Is that clear? So now even 180 is not in any quadrant, but when you subtract it or add it, it's in another quadrant. Again? Even 270 and 360. So now I'm saying what are the numbers that are between 90 and 0? Any number? 30, 45, 60, and so on. There are many, but cancel 90 is 0. It can be 89, it can be 89.5, 89.8, and so on. But it cannot reach to 90. So rather, all the angles that are in here, they are between 0 degrees and what does it mean? 90 is not included, the 0 is not included in that quadrant. Of course, some they say 0 is in the first quadrant. I don't know. So, but we're saying here, those in the first quadrant, the numbers are between that. They are not included, but anything between that. Right, what I'm saying is that, look at this one. In this quadrant, what are the numbers that we have? 150, 160, and so on. Again. Now, quickly, let's show using the numbers again. Because now you use the diagram with the x and the y's to show that how you sign in that quadrant. Again. Now let's pick any number in the first quadrant and use sign of that angle. Now, yes, any normal. It can be 45, less than 90. You must take out your calculator and try what I'm saying. You must try. Say sign of that any angle that is between 0 and 90. Why are we getting 1 over? Our interest is on the sign. We are not interested on the magnitude of the number. Yes, you are getting what? Maybe I should use operator because you are working with the trig here. There is sign in the trig. So let's use the operator again. Know that when I'm saying operator, I'm talking about the plus, minus, multiply, and divide. And also the equal sign is also an operator. But now, when I'm saying the operator, let's know that we're talking about this 4 for now. So what is the operator of that sign? Any angle? It's positive. Now try cos. What is the operator? Positive. Try tan. You also get positive. Now let's go to second quadrant. Pick any number on the second quadrant, which is the number will obviously will be between 180 and 90, or 90 between 190 and 180. Just pick the number that is between that, and then for the sign, what you're getting, you get positive. Now use cos, you get negative. Then use the tan, you also get negative. So you can see it means all these statements are also verifying that it's true. That in the second quadrant, only the sign is what? Is that clear? Now you can go to the third quadrant and you can try them all and the fourth, you can do that. You can see that those things that were written, say this is positive in this quadrant, it will remain the same again. So what does it mean? It means when you are given a number instead of the reduction, it means you must be alert that which number this number is belong to which quadrant again. Then to show that, to say this is sign of maybe 150. What is it? Is it positive or negative? So it's because we need to check first about the sign. Now, what I was saying is that if we have 150 here degrees, okay, it's in this, it's in what? Second quadrant. Now that 150 is greater than acute angle. Is that true? Or greater or if it are 90. Right? And another triangular never got acute angle. Again. Now I'm saying for me to get that acute angle, it means I know there is a boundary here. Again, I can use this number and subtract this one to get what? To get the acute angle. Again, so what will be the acute angle? 30. Wait. Then in the first quadrant, that's our one. So the ratio of 150 should be the same as the ratio of 30 in the first quadrant. The only difference will be what? The operator. The ratio, numerator and the denominator. For some of them. Is that correct? Try. Say sine of 30. You get what? Say sine of 150. You see that? So what I'm saying is that there is, if the number is more than acute, there is a cousin. That cousin of 150 or of 150 kima. Kite. So raro na lumusho mwe wa acute angle. Ole kana le na ka komara. Why what? That's what we mean by reduction. We reduce that bigger number, which is bigger. Bigger we say more than acute. Then reduce it to acute. Kaushumisha jona these numbers. The reduction numbers. So when we say reduction, we are reducing a bigger number to an acute number. Is that clear? All right. Let's try cos. Let's try cos. You know the number is 150. Alright, let's try cos 30. Okay? Let's start there, right? Yes. The bigger number that we have is how much? Let's look at that. Cos of 30 degrees equals to. Now let's check the cos of 150 degrees. Is how much? Negative root of. So what I'm saying is that this numerator over denominator. I just want to list. So that what I'm saying going that 150 cousin y go. But cousin doesn't mean they will be identical all out. But they look alike. Some small thing will be different. Yes. So that's what I'm saying, that when we have when we say reduction, we are reducing that number based on their cousins. Their cousin is the acute angle that in the first quadrant. So in mind, don't worry. About maybe that bigger number, maybe 300. You know that first quadrant. Why? That's why reduce that 300 so an acute angle. And reduce that reduce these numbers. This is the one. This one, they are saying we should avoid it. So we're also going to avoid it. So not this one. We're not going to use this one. And we're going to also use normally here, especially 360. And this one, that one is not necessarily that we are we are reducing, but that angle is on 90. Okay? So reducing it, remember, it brings us the core ratio as we did by that proof in one triangle. Okay? You still remember that? All right. So it means if that is the case, I'm saying this was what? This was the part of the reduction. Where you say 180 minus this one. This one. You see, it will be someone that is common to that in the first quadrant. Okay? Yeah? This one, it will reduce this number in such a way, this part, this theta, or this alpha, first quadrant. That's why we simply say sine of theta equals to this one. All right. Hence, now let's start to put ourselves in quadrants by using those reduction numbers. Okay. Let's start to put them in the quadrants. Now, we are in the cast diagram again. Right, on the cast diagram, 0 degrees and or maybe beginning one number straight. And then camera 180, camera like that. Maybe I didn't want to not. I want to deliver. I get more right. We know that's our 90. Now we said we use the reduction numbers. So obviously, let's get into the first quadrant. How to get in the first quadrant? Remember, but I'm feeling a certain number. It belongs to that quadrant. But I must subtract the boundary or the reduction number or add it so that I will be in that quadrant, and or in that quadrant I can get the acute angle again. All right, Arbon, I want to get in this one again. Maybe I'm feeling 45 is still fine. So how do we get in this quadrant? Is either you don't know what that number. If it's 45, you don't know what 45 plus 0 again, or so on. But I can also get used to this one again. If I say 360 degrees plus, can I remember when I say plus, I'm doing the positive angle. And the positive angle again rotate one clockwise or anti-clockwise. So anti which direction I should go that way again. So meaning I say when I say plus, I'll be going in this quadrant. So I get that direction when I'm here. I get the direction when I'm here. So running plus theta. So what is this theta? This theta is an acute angle that I must use. Because if it's more than acute angle, we're going to go to that quadrant. It doesn't be more. So that number should be less than. Or what else can I do here? Or it can be 0 degrees plus theta. And this is equivalent to theta. So any sine of theta, cos of theta, any of theta, I'll be in that angle, in that quadrant. All right. Or I can use what? 90 degrees plus or minus. So I'll say minus. If I minus, I'll be getting the quadrant again. Yeah. So minus the acute angle. Or that number will be less than 90 degrees. Is that clear? Right? Then from there, what are you going to have? Or I want to get in this quadrant. Or if I'm on 90, I should what? Plus or minus? I should say plus. Okay? So I get a plus, that will be 90 degrees plus theta. Don't forget that the theta is the acute angle. All right, from there, array. What else to get this quadrant? Minus. So in a equation, if you see 180 minus theta, quickly what's all which quadrant? Okay? You see that I mean second quadrant. Then you put yourself there and work it out. Then these two. Plus fail lagi. Kamu kita nak minus. fail. I said this one, they no go in. You don't use that. Any question? Is there anything that I'm leaving it out? So let's finish that part of the. So we've seen that if you say 180 minus, we're only going to take the which quadrant and we take our equity angle. Okay, in which quadrant and take our equity angle. Okay, because we've seen that it will be equivalent to someone in the first quadrant in that way. So it means our reduction numbers are just you locating us where or in which quadrant are we, so that we can use the other part. All right, let's finish the correlation. Let's get the first two again. That sine into 90 degrees minus theta, it will be how much? Over cos theta again. Cos into 90 degrees minus theta equals to. So because the ratio is not again. So now let's say sine into 90 degrees plus theta. So now is a ratio, but when we are going to the second quadrant again. So what will be the answer here? Cos of. Now we have the cos of 90 degrees minus theta or plus theta. What are we going to have? What are we going to have? That will be negative sine theta. Take note of that again. Negative of sine theta. So these are the core ratios. So whenever you're going to see 90, it means you must change the function again. From sine to cos, from cos to sine, depending on what you are given again. Alright, after that, if we have exhausted that, we can check the negative angles. There are negative angles. Negative angles. What do you know about negative angles? If we have the sign of negative A. So in here, simply are saying we are rotating in what? When I say negative A and acute angle, it means we are rotating in a clockwise direction again. But rotating in a clockwise direction is not what we are looking for again. So, but meaning that if you rotate in clockwise direction, we are here. Again, you are here. And then you rotate in clockwise direction, which way are you going? Up or down? Up or down? Then we'll be going down. And when we go down, how to get it into this quadrant? 360 minus. So that thing is equivalent to 360 minus angle A. So it means that will be in which quadrant? That will be in which quadrant? So we name this quadrant number 1, quadrant number 2, quadrant number 3, quadrant number 4. So in which quadrant are we? If I say 360 minus quadrant A, so you see, you have to write this to reference again. You have to write this so that you can reference. You cannot just close your eyes and say, I will remember. This is your weapon. We must write it down so that you refer to that again. When you get there, you write it while you are in the exam, when they say start writing again. So that now you can refer to that. Alright, so it means how is sine in the fourth quadrant? Negative sine of angle A. Cos negative of A, what will be? Positive cos of angle A again. Tan of negative angle A, what will be? After negative tan A, what does it mean? In other words, what is it that is negative in that quadrant? Yes, it's the angle in that quadrant. So the ratio are the ones that are negative. So when you say tan of this one, remember this is going to be replaced by the ratio, which is y over. So it means that the ratio is what? Negative. Don't be confused. It's not the angle. Because we are saying tan of that angle is negative. What does it mean? It means the ratio, the division of that sides that are making that angle A, that they are going to give us a negative ratio. All right. Now, after that, now we can go to the examples and see if, yes. Yes, it's correct. The method is correct, but you must do it with understanding. Agree with when you say negative A or negative 10, of course you can put your angle there. Again, then when you put your angle, what is negative 10? Is which quadrant? A. A. You see, the calculator is just giving you the sign. That sign is negative if it's the sign of negative 10. But clearly, you see, you don't see where is that. So we're going to give us the problem when we need to draw the diagram. So that's why we say apply it. That one is there when you understand. It's just to spice it up to finish quickly, knowing the expected answer. Yeah? But through the steps, it might give you a challenge. Hence, I say you cannot point where is negative 12, negative 10 degrees. But now with your understanding, I told you that negative, we are going from clockwise direction. So any number that is going to be negative and is an acute, of course, will belong to this quadrant. Now, where is the 0? The 0 is only here. So how can it be that negative 10? It will only be here. Unless we have negative, what will be the number here? What will be the number here? If here is negative 10 somewhere here, what will be the number? A. Negative what? You see, that is the problem with the calculator. So, yeah, I don't disagree with you, but I'm saying do use calculator with understanding. But whenever you just use calculator to shortcut things without understanding, at some point, at the simplifying part, we're going to have a challenge. So it means if you are here, you are going negative clockwise. This will be negative 90. Because from here to here is 90. So when you are moving in other way around, take this in your mind. When you are moving in that direction, is anti. Anti means opposal. Nakanala wachika mpolisipela gawa. Wazwa chela nakanala sipela gawa. Oppose. That's what it's anti. Well, then we measure the positive angles. That's why plus positive angles. When you go to the direction of watch, is clockwise. Come watch is clockwise. So again, then that would be negative angles. So anything from 0, move in that direction, anything is going to be negative. But from here to here, it's a quarter. Each quarter is worth 90. So from here to here to be negative 90. From here to here to be, then when you say 90 to 90, it will be negative 180. Then that will be negative 270 and so on. So you can use your calculator but be careful. Understand what is it that you are getting. So when you say sine of negative 10, where sine is negative, it cannot be in the third quadrant. Yes, it's saying negative. Where is sine? Sine is negative in two quadrants. It's in this quadrant and this quadrant. But where is negative 10 in which quadrant? Negative 10 now you have to know. And when I was by that time, when it was very negative. Then if you say draw diagram, you start to struggle. Why what? So be careful of what this is. So then you remind me of something. I forgot to mention it. But now it's what we're going through now. This stage. Now look at your diagram where I said we're moving or sine positive in which quadrant, negative in which quadrant. Okay. So even if you look at this one, sine is positive in which quadrant? Second and what? What? Then as sine fair, let's say cos who positive in which quadrant? Then cos or negative in which quadrant? Second. And can you see everyone appears twice? The nature of that operator appears in two quadrants. So when I'm not by negative, you don't know which quadrant, then we're going to solve. You must wait for the second condition. Of course, but I will expect which quadrant and which quadrant. Then the next condition will take away that again. So, but we'll get into it. That's why I'm surprised if you are bored. This revision is boring. That should be more interesting because you have some gaps, and you have to fill those gaps again. So I cannot just start with compound because our grade 12 syllabus is compound. So, but I have to make sure that we have the basics correctly, just reminding. Then from there, we can get compound so that we can rush when we get there. Because now we'll be having everything that we need as the basics. We'll need this one. And then you must make sure that you understand these basics. You don't just cram. All right, let's get the question. And then is this quadrant. And then they're saying this is B. This is, of course, that will be O. But the angle starting from here up to here. Then this angle is called an alpha. And then this B is having the coordinates of 3 and negative 3 root of 3. Negative 3 root of 3. Okay. Let's see. And that's it. This is point X, and this is point O. Given that X angle OB is an alpha and B is this one. Okay. Now, after having this diagram, they will ask you the question. So, there are questions here. Let me write 2 because time is against us. After that, they are saying determine. Remember, this is the first questioning of TRIG. That's what you must expect in the first questions. Again, you must expect something like this. So when you practice, please make sure that you do them parts by parts. You don't just go throughout again. Make sure that you target the first question first, then you do that. Number 1, they're saying determine OB. Number 2, determine the cos of negative alpha. Number 3, determine the sine of 180 degrees minus or plus alpha. Number 4 is minus 1 over the square root of 3 sine of alpha. plus 2. Alright, let's run quickly and finish this one. Now you are going to see our basics are going to come in. Alright, given this information, now they want the OB. What is OB? OB is this one. But now, before you answer this kind of question, you must make sure that your diagram is complete. Okay? So that diagram, if it's complete, it must have the X, Y, R, and of course the angle is given. Okay? So just make sure that the X, Y, R are there. Alright? Then what is left here? What is this one? That will be X. So we can draw this one. You know that will be 90. Then X in this quadrant is what? Of course, it's positive. Okay? So that will be 3. And then this one is what? 1. So that will be negative 3 square root of 3. Then what is left? We need R. How to get R? That will be Pythagoras again. What is saying? Is saying the hypotenuse squared is equals to the sum of adjacent squared plus the opposite squared. In weights again. The hypotenuse squared equals to the adjacent squared plus the opposite squared, or whichever way. So now you know in this way we have the opposite and the adjacent in terms of X, Y, R again. So now the first one, and our R you can see is OB again. So if it's OB, it means OB squared equals to what? Equals to you can have that O X squared plus X B squared. Is that clear? So now OB squared equals to, now what is OX? 3 squared plus negative 3 root of all squared again. Alright, OB squared equals to 9 plus 27. So OB squared equals to 36. So OB equals to plus minus the square root of 36. What is it? It's 6. This is positive 6 again. Because now the R is positive. You must mention this plus or minus, because square is showing that we're going to get two values again. So make sure that you write plus or minus, therefore you'll choose the correct one. So we have 6. So this 6. Our diagram is now complete again. So if it's complete, now what will be cos of alpha or cos of negative alpha? What are you going to get? You get, now you must simplify this one first, because you see a negative angle is a rejection again. So simplify first, you get what? Cos of alpha. So what is cos of alpha? Yoba, cos is what? You have your soccer through you. Then you say cos is what? Adjacent over. What is the adjacent? There. Is 3. The adjacent is 3. Again, remember we said whatever way we present this one will be the same as the acute angle in here again. So we just work it as if it's here. Remember guys, if this alpha is here again. So all the more doing this is the adjacent, this is the opposite of this alpha. So but I showed you why are we doing that again. So 3 over 6. Is this simplified? Is this simplified? So what should be the answer? 1 over, that would be 1 over 2. If you leave it here, no mark for the answer. You must simplify. Otherwise, no mark. Alright, let's get to this one. Sine of 180 degrees plus alpha. What will be the answer? We must reduce this first again. It shows a reduction. What do you get? Negative sine. Everyone knows where it's coming from again. So what is that? What does it mean? 180 plus which quadrant are we? Which quadrant? Third. How is sine in third quadrant? Then you start by writing negative. But this is not a thing that will change the function again. Then that will remain sine. equals to negative into what is sine of alpha according to the diagram? Negative 3 square root of 3. Negative 3 root of 3 over 6, like that. So what is the simplified answer? Negative square root of, that will be positive, okay? Square root of 3 over 2, because negative by negative, positive. Now from here, when after substitution, you can use your calculator, but they say with the aid of the diagram without using calculator. What does it mean? It means you must not write your answer in decimal form. When I say use the without the use of the calculator. The last one. Negative 1 over square root of 3, because we cannot substitute that again. So, but we have the sign of alpha. What will be the sign of alpha? Yoba? What will be sign of alpha? Eh? Up, you have to put yourself in a diagram. Sign of alpha. Sign again over here. What is the opposite when you are here? Then you must write what you see there. Negative 3 over root of. What is the hypotenuse? Then you say 6. You see why you are taking time to give me the answer? Because you are looking at the board, and on the board there is no soccer tour. And then you should be having your soccer tour on yourself. And then you should be having what? The cast diagram at the same time. And then now that's when we can look at this diagram. Say, okay, now I have the sign. Look at this one. I have the sign of what? Alpha. Is there any alpha on my diagram? Then I can use the diagram to replace this whole thing of sine alpha. Because I know this sine alpha is giving us the relationship between the two sides. So I'm going to replace that with the ratio of the sides. Then now press calculator and tell me what you get here. You get 5 over, yeah, plus 2. This one, there is plus 2. So what is the final answer? 5 over 2. So there was this plus 2 there. It should be there as part of the solution when I go in there. Is there any question? Now, the other hint that you must take care of. Let me check. Okay, it's fine. We'll talk about it some other time. But what I wanted to say maybe is that this diagram is in which quadrant? It's in fourth quadrant again. And then look at this one. This one is what? Is sine theta and sine alpha. How is sine in the third quadrant? Then you can see here we substitute a negative angle. What? So or indeed that sign of that angle in that quadrant, is it again substitute, is it positive or negative now again? So sometimes they help, but check it when you do the substitution. Is there any question? Then I will stop there.